Next, let's start with the elimination reaction. Before explaining the concept of elimination reaction, let me explain what is an alpha carbon, alpha hydrogen, beta carbon, beta hydrogen. Alpha carbon means we know different functional groups like aldehydes, ketones, carboxylic acid, alcohols, etc. The carbon which is attached to a functional group, that is called alpha carbon, and the hydrogen attached to this is called alpha hydrogen. Beta carbon means the carbon which is attached next to the alpha carbon, that is alpha carbon, and hydrogen attached to this carbon is called beta hydrogen. Then gamma carbon, gamma hydrogen, like that it will go. Now consider this reaction. The valencies of carbon should be satisfied. X is called the leaving group. It pulls electron towards itself. Thereby, the separation of X minus is facilitated. So because of this, this carbon will be positive. So the electrons binding this carbon and hydrogen will be pulled here. So this H will be having a positive charge. So a base or a nucleophile is here. So that will be getting attached to H to form BH. Then after this arrangement, rearrangement forms an alkene along with the separation of X minus. Here, if there are more than one beta hydrogen atom, the formation of more than one alkene also will be there. This concept was well explained by the scientist Alexander Saytzeff, which we call it as a Saytzeff rule. Another important rule, Saytzeff rule. So in order to explain that concept, please go through this reaction. 2-bromopentane. The reaction of 2-bromopentane with a nucleophile. So this is the functional. What about this carbon? What is this carbon and what is this carbon? So please understand that. So more than one beta carbon and beta hydrogen. So the formation of two alkenes will be there. In the first case, so I have split this CH3 as CH2H. Okay, for an easy understanding purpose. So in the first case, pent2-ene is the alkane, and in the second case, pent1-ene. Here the chance of formation is 81% for pent2-ene and 19% for pent1-ene. So actually this is Saytzeff rule. In dehydrohalogenation reaction, the preferred product is that alkene which has greater number of alkyl groups attached to the doubly bonded carbon atoms. You have to find out where the greater number of alkyl groups attached to the doubly bonded carbon atom. See this product, see the doubly bonded carbon. So see this product. Okay, so according to Saytzeff rule, pent2-ene is the major product and pent1-ene is the minor product. Next, let's see what is elimination reaction versus substitution reaction. Actually, a chemical reaction means it's just like a competition. An alkyl halide with beta hydrogen atom, when it is treated with a base or a nucleophile, it has two competing routes: substitution reaction and elimination reaction. So substitution reaction means, you know well, It is again categorized as SN2 reaction and SN1 reaction, along with the elimination reaction. A primary alkyl halide will prefer to SN2 reaction. A secondary alkyl halide will prefer to elimination reaction or SN2 reaction. This depends on the strength, size of the base or nucleophile. And in the case of a tertiary alkyl halide, SN1 reaction or elimination reaction takes place. That depends on the stability of the carbocation thus obtained. Okay. So please have a look on this. Thank you.